In exercise number 7.2, today we have to see the example number 9. Minimize z is equal to 7x plus y subject to 5x plus y is greater than or equal to 5, x plus y is greater than or equal to 3, and non-negativity functions x is greater than or equal to 0 and y is greater than or equal to 0. Solution: write inequations as equalities. This inequality is equalities, that is constraints. 5x plus y is equal to 5, equation number 1. Second, x plus y is equal to 3, equation number 2. We have to calculate the points A, B, C, D from these two linear equations. First case, put x is equal to 0 in equation number 1. Equation मध्ये x value 0 ठेवायची. Therefore, we have to get y is equal to 5. That is a point. We have to write the x coordinate first and y coordinate second. 0, 5. Case second, put y is equal to 0 in equation number 1. That is 5x is equal to 5. Therefore, x is equal to 1. Therefore, b point 1, 0. Similarly, put x is equal to 0 in equation number 2. We get y is equal to 3. Therefore, c point 0, 3, and y is equal to 0 in equation number 2. X is equal to 3. That is d point 30. Then these 4 points are plotted to the graph. Then we have to take x coordinate, x axis, y axis, origin 0, 0, x dash, y dash. Your all points are in first quadrant. Therefore, your graph is on the first quadrant. Right? That is, we have to given conditions. X and y is greater than or equal to 0. Therefore, our graph is on the first quadrant. Then we have to plot first point 0, 5. 0 on x axis, y 5 is on y axis. That is a point. Next point b 1, 0. 1 is on x axis. 0 is on y axis. That is b point. Similarly, c point 0, 3. 0 is on x axis, 3 is on y axis. And 3, 0, d point. 3 is on x axis, 0 is on y axis. Therefore, these points are in x axis. Then we have to join a and b. We have to join a and b. That is the equation 5x plus y is equal to 5. Then second line CD. CD is equations x plus y is equal to 3. These lines are we have to join. Then we have to take feasible region. We have to given equations greater than or equal to or minimize the function. Therefore, we have to take the your feasible region or shaded region is on the outside the origin. Therefore, this x axis, this is our shaded region. Therefore, corner, we have to take corner point method. Therefore, corners of this shaded region or feasible region are D, P, and A. Therefore, our feasible region will be X axis. Alright, X, D, P, A, Y. Our feasible region is X, D, P, A, Y. We have to given corner points D and A, but not P. Therefore, we have to calculate point P from the two equations. Which two equations? The two linear equations of these lines. First equation is 5x plus y is equal to 5, and second equation is x plus y is equal to 3. Therefore, we have to solve these two linear equations. We have to get x is equal to 1 by 2, that is 0.5, and y is equal to 5 by 2 is 2.5. Therefore this point P is x 0.5 and y 2.5. We have to get point P and feasible region, that is x, d, p, a, y. Then we have to calculate the minimum value of the objective function z. ये फंक्शन दिलेला आहे, the minimum value of the objective function z. ग्राफ झाल्यानंतर आपण काय करणार, फिजिबल रिजन दाखवलेला आहे x, d, p, a, y. त्यानंतर पॉइंट P काढलेला आहे 0.5 आणि 2.5. देन द मिनिमम value of objective function z at the corner points D, P, A will be at the corner point this D, this P and this A. या 3 कॉर्नर पॉइंटला आपल्याला फिजिबल ऑब्जेक्टिव्ह फंक्शनची व्हॅल्यू काढायची. पण therefore first point D, z, that is objective function z at point D 30. D किती आहे 30. याचा अर्थ काय रे, x व्हॅल्यू 3 आणि y ची 0. then we have to put these values. Which function? Objective function. 7x plus y is equal to 7 into x is 7 into 3 plus 0. It is y is 0. It is 21. Next at point P, z, the objective function z at point P 0.5 to 0.5 is, the value of x is 0.5 and the value of y is 2.5. Put these values in this objective function, then we have to get 6. We have to get 6. The next, z at point D, P, A is 0.5. Then we have to take 0 as x, 5 as y. Therefore we have to get the value y. आपल्याला मिनिमम व्हॅल्यू विचारली पहा ऑब्जेक्टिव्ह फंक्शनची. Therefore the minimum value of the objective function z, आपलं z काय असतंय ऑब्जेक्टिव्ह फंक्शन. Therefore the minimum value of the objective function z is 5 at point A 0.5. at point A 0.5 म्हणजे ही व्हॅल्यू आपली मिनिमम आली. त्यापेक्षा ती जास्त आहे आणि त्यापेक्षा इकडे जास्त आहे, मोठे. इट इज द मिनिमम व्हॅल्यू. मॅक्झिमम आहे त्या 5 पेक्षा. त्यामुळे आपण आन्सर काय लिहित, आपल्याला मिनिमाइज विचारले मिनिमम व्हॅल्यू. त्यामुळे द मिनिमम व्हॅल्यू ऑफ द ऑब्जेक्टिव्ह फंक्शन z इज 5 at point A 0.5. Next, write down next example. Write down next example. Example number. Similarly, we have to solve example number 10. Similarly, we have to solve example number 10. Write down. Minimize. Minimize. Z is equal to 20x1 plus 9x2. 20x1 plus 9x2 subject to write down constraints. 2x1 plus x2. 2x1 plus x2 is greater than or equal to 36. Second constraint. 6x1 plus x2 is greater than or equal to 60. Non-negativity functions. x1 greater than or equal to 0, x2 greater than or equal to 0. We have to solve this linear equation, minimize of the above equation. Next, write down example number 11. We have to solve of this type. We have to take minimize. Next, example number 12. Minimize. Z is equal to, minimize Z is equal to 6x1 plus 2x2. 6x1 plus 2x2 subject to the constraints. Subject to the constraints 5x1 plus 9x2 5x1 plus 9x2 is less than or equal to 90. Next constraint, x1 plus x2 is greater than or equal to 4, and third constraint, x2 is less than or equal to 8, x1 greater than or equal to 0, x2 greater than or equal to 0. आता ठिकाणी तीन कन्स्टंट दिलेत, पण काय लेस दॅन दिलेत, काय ग्रेटर दॅन दिलेत, आणि काय विचार आपल्याला ऑब्जेक्टिव्ह फंक्शन काय दिलं, मिनिमाइज हिज ऑब्जेक्टिव्ह फंक्शन, that is z is equal to 6x1 plus